Hi guys, in this video we're going to take some notes about the classification of matter. We did a lab the other day where you separated out some mixtures, and so we'll talk about those mixtures a little bit more. And we did an activity where you looked at some particles. And we can't see real particles, so we had to look at some paper particles instead. But you separated those into some common categories and separated those categories out a little bit more, and so we're going to write down what those different classifications are and sum it all up in this lovely graphic organizer. So this is available on Shobi, or you can have a paper copy. It's up to you. I'm going to be writing on this paper copy because that makes it a little bit easier. So we're going to start up here at the top, and we're going to write a definition for matter. And matter, we've already defined before. Matter is anything that has mass and takes up space. And mass, oddly enough, is defined as the amount of matter, so that's kind of a little bit circular there, but we measure it in grams. And it has weight here on Earth because gravity pulls on it, but space, the fancy word for space, is volume. You have to be able to measure a volume. And matter is a pretty important deal because chemistry is the study of matter. Remember that? So our whole purpose in chemistry is to learn more about matter and also how it changes. Chemistry is the study of matter and its changes. So we're going to start looking at just different types of matter, and next semester we're going to get into what happens when that matter changes and how we can define those things. So let's start on this side of the chart here. So when you first separated them out, you had two sets of particles. You had samples where all the particles were the same, and we called those a pure substance. And so we're going to define that as all, well, this is a description first. All the particles are the same. In a pure substance, all the particles are the same. Now, they might be atoms, they might be molecules, but all the particles are the same. So our technical definition is this. It is matter with a constant composition. I ran out of room there. Constant composition and definite properties. So we can know exactly what it is by measuring some things about the substance. There's no question about what oxygen is going to do. There's no question about aluminum. These are some examples of pure substances. So there are constant properties and constant composition. Any sample of aluminum is going to be exactly the same kind of thing. So on the other side, instead of pure substances, if it's not a pure substance, then it's a mixture. And a mixture is some combination, a combination of different particles. So either your particles are all the same and it's a pure substance, or they're different particles and it's a mixture. And the technical definition here is that we have matter with a varying composition. So a mixture doesn't have to have the same composition every single time. Every piece of aluminum foil is made up of aluminum, which is just a bunch of aluminum atoms. But chocolate chip cookies don't have to be exactly the same. Some people put pecans in their chocolate chip cookies. Some people use the big chips. Some people use the little chips. The composition isn't exactly the same. Some chocolate chip cookies call for more sugar in the recipe, and some call for more brown sugar in the recipe. So it really just depends on what you're looking at. So when you look at pure substances and mixtures, we use some things called chemical formulas, which I'm going to jot up here. A chemical formula is a set of letters that represent what is in a substance. Okay. Now, when you write a chemical formula, we looked at some chemical formulas before, but do you remember in kindergarten when you had that lined paper that helped you figure out how big to write things? When you write a chemical formula, there are capital letters that are nice and big, okay, and there are lowercase letters. That would be small. I'm trying to think of a good lowercase. All the ones I can think of have capital letters off the top of my head. Okay, we're just going to do water. The capital letters are capital, which means they're nice and big, and your lowercase letters would be extra small. And then there are those little numbers in there. They're called subscript numbers. That means their sub means below, and we always write them a little bit smaller. So it's about the same size as a lowercase letter, but it's below. So H2O is how we would write this. This would be water. Now H2O is not right, but the 2 is too big. H2O is not right. The 2 is up high. That would be more like H squared, which you might be familiar with writing squared in math class, but this is not the same thing as squared. We're not multiplying H by itself. We just have 2 H's in there, so it's H2O. Another combination that I've seen would be H2O or something like that, but we always use capital letters or lowercase, and those letters are in the periodic table, which you don't have one yet, but some of these letters you need to memorize, and there's a list in Shobi. So when you're looking at a pure substance or a mixture, you can look at the chemical formulas and know if there is a single formula, then you are looking at a pure substance, a single formula. If you have an and in there, you have formulas with and or an and sign in between, then you are talking about a mixture. Milk is a mixture. Milk has water, it has fats, it has protein, it has vitamins. It is a mixture of things. In fact, it's got so many things that it would be silly to try and write down a formula for it, because it would have, I don't know, 6 or 8 different things with an and sign in between, possibly more than that. So if you see an and, then you know you're talking about a mixture. If you don't see an and, you know you're talking about a pure substance. So after you separated out your mixtures, you took a look at the pure substances and separated them further, and you found some compounds and some elements. And with your compounds, you found that that there was more than one kind of atom. Okay, so this is matter, composed of molecules. We call those groups of atoms molecules that have more than one kind of atom. So a molecule is the smallest part. Molecules are the smallest part. Okay? If you cut up a molecule in a compound, it stops being the compound. We took some water and we ran some electricity through it, and we broke it up into the hydrogen and oxygen that make it. And the hydrogen wasn't the same as the water. It was a gas, and the oxygen wasn't the same as the water. It was a gas too. So we had 2 different kinds of elements in there, and together they make water. Apart, they both are involved in fires. So we don't catch water on fire, we catch other things on fire. So you can't break the molecules. And I'm going to say by physical means here, we had to use electricity to do it. Physical means. We had to use electricity to break up the particles. We didn't boil it. We didn't run it through a filter. You can't get the hydrogen and the oxygen out of water that way. You have to use chemical means, like running it through electricity or reacting it with some other elements or other compounds. So when we talked about elements, you had matter, and it was composed of only one kind of atom. So if you have all the same atoms, it's an element. If you have different atoms, it's a compound. Same, different, that's an R, okay? So here, over with our compounds, a molecule was the smallest piece. In our element, atoms, are the smallest part. So some examples of some compounds. Water is the most famous compound, H2O, and salt is another compound that you're familiar with. Salt is made up of sodium, Na, and chlorine, which is Cl. And I try to write my L a little cursive so I don't confuse it with my I's. And some examples of some elements would be aluminum. Aluminum is an element, Al. And helium is an element. If you ever had a helium balloon, you had an element in that balloon. And if you'll notice by looking at the letters, those chemical formulas, here we have more than one capital letter. It's the capital letters that separate out the elements. If there's more than one capital letter, you're looking at a compound. And if you have only one capital letter, then you're looking, capital letter, then you're looking at a compound. So that's elements and compounds. That's only half of matter. The other half is mixtures. Most things in the world are mixtures. And there's two kinds of mixtures, homogeneous and heterogeneous. Heterogeneous. And you can say that homogeneous and heterogeneous too if you'd like. Both are acceptable. And when you see that word homo, you're familiar with that word. It means the same. And when we're talking about mixtures, what's the same is what it looks like, the samples. The samples of the mixture are the same. If I took Kool-Aid and poured a couple of glasses of Kool-Aid, they would be the same. There wouldn't be a difference. So another way to think about this is that it is a uniform appearance, and that means that you can't see the parts. You can't see the parts. So if you look at something and you know it's not a compound or an element, but you know that there's pieces to it and you can't see them, you can't see the water, you can't see the sugar, you can't see the flavor or the color in the Kool-Aid, you just see the Kool-Aid. You're looking at a homogeneous mixture. So air is a good example, and I just said Kool-Aid. And if you look here, this tabletop is made up of a bunch of different things, but I can't see the individual pieces. So the tabletop is also a homogeneous mixture. Now, heterogeneous mixtures, hetero is the opposite of homo. Hetero means different. So in a heterogeneous mixture, the samples, two samples of the mixture, are different. I think I'm going to run out of word there. Okay. They're different. And what that would look like to you is that the appearance would be non-uniform appearance. And you would be able to see, you can see the parts. So there's lots. So you can see the different parts in a heterogeneous mixture. This pen is a heterogeneous mixture. There's the little tube of ink inside and the outside of the pen, and the part that actually does the writing, which wrote on my hand a little bit. My hand is a heterogeneous mixture. I have skin and fingernails. If you could cut it open, you could see muscles and bone and blood vessels. It would be a lot of different parts that you can see. You can't see the parts in a homogeneous mixture, and you can see the parts in a heterogeneous mixture. So some examples, my favorite is chicken noodle soup. Every bite might have a different set of things in there. Chocolate chip cookies would be also. You are a heterogeneous mixture. And one more, how about concrete? Concrete is a heterogeneous mixture. You can see the rocks in there sometime, and different concretes have different mixtures or different compositions anyway. So this is, I think I can fit most of this in the screen. This is pretty much it that you need to know for how matter is organized. Thanks for watching.